Imagine blasting across the Atlantic in under 90 minutes, or jetting to the other side of the planet in just a few hours. It's the kind of travel you'd expect to find in a sci-fi film, but it's closer than you might think. Hypersonic technology that will have us covering vast distances at mind-bending speeds is more than a dream. It's on the verge of becoming a reality. Aviation pioneers like the Concorde once brought us closer to the concept, and ambitious plans like the Boeing 2707 hinted at it. Now, Hermeus, a company few have heard of until recently, is taking hypersonic to new heights with its revolutionary engine, the Chimera. Buckle up as we check out the technical wonder that is the Chimera and the game-changing impact it could have on aviation, travel, and even national defense. The supersonic Concorde was a technological marvel in its day. With flights cruising at Mach 2, it drastically cut transatlantic travel time. However, the Concorde had limits, many of which stemmed from its own technology. High operational costs and low efficiency ultimately grounded this feat of engineering. Meanwhile, in the 1970s, Boeing took a stab at the next frontier with its 2707 project, a concept for an American supersonic airliner that could reach Mach 3. Unfortunately, the 2707 never left the drawing board. But despite these setbacks, the dream of hypersonic flight lived on in the minds of engineers. Now, Hermeus has taken up the challenge. Founded in 2018, Hermeus brought together a group of experts from aerospace giants like SpaceX and Blue Origin. These innovators weren't satisfied with small steps. They wanted to break new ground. Their solution? The Chimera Engine, a turbine-based combined cycle, or TBCC design that's practical, powerful, and groundbreaking. Unlike experimental engines such as the scramjets used by NASA in aircraft like the X-43, the Chimera builds upon jet engine technology that's been tested and refined for decades. Hermeus's goal is to make hypersonic travel feasible, affordable, and adaptable. The Chimera is their ticket to achieving that. So what makes the Chimera engine so special? It's a TBCC engine, meaning it combines different propulsion technologies to achieve maximum performance across a wide range of speeds. At lower speeds, it operates as a traditional turbojet, compressing incoming air, mixing it with fuel, and generating thrust through combustion. This approach leverages well-understood technology, giving Hermeus a strong foundation upon which to build. But when the Chimera hits higher speeds, around Mach 3, it undergoes a transformation, switching to ramjet mode. Here, the incredible speed of the aircraft compresses the air inside the engine, and when the fuel ignites, the Chimera delivers the powerful thrust necessary for sustained hypersonic flight. Traditional turbojet engines encounter serious limitations at speeds around Mach 2 or Mach 3. At these speeds, the air entering the engine heats up significantly, stressing engine components and reducing performance. Hermeus has tackled this issue head-on with a proprietary pre-cooler system. This device rapidly lowers the temperature of incoming air, allowing the turbojet section of the Chimera to function effectively at speeds beyond what standard turbojets could handle. By cooling the air before it enters the combustion chamber, the Chimera can sustain performance and maintain efficiency at hypersonic speeds. The brilliance of the Chimera is that it doesn't need rocket boosters or complicated scramjet systems to reach these speeds. Unlike some experimental hypersonic vehicles that require additional assistance to reach Mach 5, an aircraft powered by the Chimera engine can take off and land like a conventional jet. This not only simplifies operations, but also reduces costs. Plus, the extreme temperatures and pressures associated with hypersonic flight demand advanced materials. Hermeus has responded by incorporating heat-resistant alloys such as Inconel 718 and cutting-edge 3D printing techniques to produce complex engine components. These innovations enable the Chimera to withstand the unique stresses of hypersonic travel. The Chimera isn't just about speed, it's about practicality, reusability, and scalability. While other hypersonic technologies aim to set speed records, Hermeus is focused on creating a hypersonic engine that can be used repeatedly and adapted for a variety of applications. Imagine the impact on industries like rapid cargo transport, where time-sensitive shipments could be delivered at unprecedented speeds. Or consider the defense sector, where hypersonic capabilities could offer strategic advantages on a global scale. The key to the Chimera's success lies in its reusability. Unlike one-off rockets or complex scramjets that are limited to a single use, the Chimera allows an aircraft to take off, fly at hypersonic speeds, and land again, ready for another mission. This lowers operational costs and opens up possibilities for faster, more frequent flights. By using proven turbojet technology and focusing on innovative solutions in areas like the pre-cooler, Hermeus aims to break down the high costs traditionally associated with hypersonic technology. Reaching speeds beyond Mach 5 generates immense heat, enough to melt or deform most conventional materials. Hermeus has taken advantage of advanced 3D printing to create engine parts that can endure these extreme conditions. The use of Inconel 718, a heat-resistant alloy, further boosts the engine's durability, allowing the Chimera to operate in environments that would destroy other engines. These technological advancements make hypersonic travel more practical and bring us closer to a future where hypersonic technology is widely accessible. The Chimera engine is part of a larger vision, embodied by Hermeus's quarter-horse Mk1 program. Rather than building a single aircraft, Hermeus is developing a series of prototypes to refine and validate their technology. The quarter-horse Mk1 is the latest iteration, designed specifically to test the Chimera engine's capabilities. In collaboration with the U.S. Air Force, Hermeus has conducted extensive ground tests at the Arnold Engineering Development Complex, examining the engine's performance across various conditions and ensuring its readiness for hypersonic flight. The quarter-horse Mk1 marks a significant milestone for Hermeus. This aircraft is equipped to take off and land autonomously, demonstrating the Chimera engine's potential for real-world applications. With each new test, the quarter-horse pushes the boundaries of what's possible, aiming to surpass the speed records set by legends like the SR-71 Blackbird. But the objective here isn't merely to reach new speeds. Hermeus is gathering invaluable data on the aircraft's performance at the edges of its capabilities, data that will inform future designs. Hermeus's rapid development philosophy allows them to build on each success. The lessons learned from the quarter-horse Mk1 feed directly into future projects, such as the Dark Horse and Halcyon. Dark Horse, a stealthy hypersonic drone, is designed for defense applications, while Halcyon represents Hermeus's vision for commercial hypersonic travel. This iterative approach enables Hermeus to optimize its technology, taking hypersonic flight from the realm of experimental prototypes to scalable systems with real-world applications. The quarter-horse Mk1 isn't just about setting records, it's about pioneering a new era of aviation. The data gathered from each test supports Hermeus's broader goals, such as creating defense-focused aircraft that can operate at hypersonic speeds or building commercial airliners capable of crossing continents in a matter of hours. These advancements don't just push technological boundaries, they pave the way for a future where hypersonic flight is a practical tool for military, commercial, and logistical applications. As part of its broader strategy, Hermeus is developing Dark Horse, an unmanned hypersonic drone designed for intelligence, surveillance, and reconnaissance. Imagine needing to gather information on a situation halfway across the globe. With Dark Horse, it's like having a super-fast spy plane that can arrive, observe, and return before traditional aircraft could even take off. Dark Horse represents the potential for hypersonic technology to provide a new strategic edge, particularly in contested regions. Halcyon is another step in Hermeus's ambitious vision, a passenger aircraft that can make hypersonic travel accessible to the public. Imagine being able to fly from New York to Tokyo in under 2 hours. While hypersonic technology has often been seen as a tool for defense, Hermeus envisions a future where it reshapes commercial aviation as well, connecting people across vast distances with unprecedented speed. The implications of hypersonic technology extend beyond travel and logistics. As global tensions rise, nations like China are developing hypersonic missiles capable of bypassing conventional defense systems. The United States is recognizing the urgency to advance its own hypersonic capabilities, not just to keep pace, but to lead. The Chimera Engine and the advancements made through the quarter-horse program could play a crucial role in future defense strategies, enabling the U.S. to counter hypersonic threats and maintain its technological edge. Hypersonic weapons pose unique challenges due to their extreme speed, maneuverability, and unpredictable flight paths. The Chimera's advancements in speed, reusability, and control could directly contribute to the development of defensive countermeasures. Imagine a hypersonic drone capable of intercepting or neutralizing an incoming threat. Such capabilities could redefine military engagements and provide a strategic advantage in future conflicts. The quarter horse's adaptability for autonomous flight also opens up new possibilities for rapid deployment. A hypersonic drone, launched on demand, could reach critical areas faster than any conventional aircraft, providing valuable intelligence or rapid response in contested areas. This technology could be a game changer for national security, allowing the United States to project power and gather intelligence with unprecedented speed. The question remains, will hypersonic technology reshape commercial aviation, or will it find its primary role in defense? The answer has profound implications for how we travel, conduct trade, and approach global security. The path Hermeus is forging with the Chimera Engine and the quarter-horse program is more than a technological leap. It's a glimpse into a future where hypersonic flight is an integral part of our world. As we watch Hermeus break new ground, we're left wondering what the next decade holds. Will sleek, hypersonic airliners transport us across continents, or will hypersonic weapons dominate the skies? Either way, the hypersonic revolution is here, and it's transforming more than just aviation. It's shaping the future.